NEC 2023 Article 347.6 Reduction in size of conduit states that a conduit may be reduced in size at any point between pull boxes or other junction points, provided that the smaller conduit is large enough for the conductors contained therein. The NEC does not specifically address the reduction of rigid galvanized steel conduit, often called RGS conduit, midstream. However, the general rule for reducing the size of any conduit is that the smaller conduit must be large enough for the conductors contained therein. Consider the scenario where a 3-inch RGS conduit is reduced to 2-inch RGS midstream. In this case, the wires must be sized for the 2-inch conduit in accordance with Table 310.16 of the NEC. This means that the allowable ampacity of the conductors must be appropriate for the 2-inch conduit. It is permissible to reduce the size of a buried 3-inch RGS conduit to 2-inch RGS midstream, provided that the wires are sized for the 2-inch conduit. This requirement ensures that the conductors are not overloaded and that the electrical system operates safely. The concept of conduit fill is central to understanding this requirement. Conduit fill refers to the percentage of the cross-sectional area of a conduit that is occupied by conductors. The NEC specifies maximum allowable conduit fill percentages to prevent overheating and to facilitate the pulling of conductors. When reducing conduit size, it is crucial to ensure that the conductors plus any other items like inner duct do not exceed the allowable fill percentage for the smaller conduit. Table 310.16 provides the allowable ampacities for conductors based on their size, insulation type, and operating temperature. These ampacities are based on specific conditions such as the number of conductors in a raceway or cable, the ambient temperature, and the presence of other heat sources. When sizing conductors for a reduced conduit, it is important to consider all applicable correction and adjustment factors to ensure that the conductors are adequately protected. First, determine the load requirements. Calculate the total current that the conductors will be carrying. This calculation should include all applicable demand factors and any other adjustments required by the NEC. Secondly, select the appropriate conductor size based on the calculated current and the allowable ampacities in Table 310.16. Be sure to consider the insulation type and temperature rating of the conductors, as well as any correction or adjustment factors that may apply. Thirdly, verify that the selected conductors will fit within the reduced conduit. Use the conduit fill tables in Chapter 9 of the NEC to determine the maximum number and size of conductors that can be installed in the 2-inch RGS conduit. Finally, ensure that the reduced conduit is adequately supported and protected. Follow the NEC requirements for conduit support and securement, and take steps to protect the conduit from physical damage. When dealing with electrical installations, several considerations and best practices should be taken into account to ensure safety, compliance, and optimal performance. First is proper planning and design. Before commencing any electrical work, create a detailed plan that outlines the scope of the project, the materials required, and the installation methods to be employed. Consider factors such as load calculations, voltage drop, and conductor sizing to ensure that the electrical system is properly designed and meets all applicable codes and standards. Second is compliance with electrical codes and standards. Adhere to the latest edition of the NEC, as well as any local codes or regulations that may apply. Familiarize yourself with the specific requirements for the type of installation you are performing, and ensure that all work is performed in accordance with these requirements. Third is the use of appropriate materials and equipment. Use only electrical materials and equipment that are listed or labeled by a recognized testing laboratory, such as Underwriters Laboratories or Intertek. Ensure that all materials and equipment are suitable for the intended application and are installed in accordance with the manufacturer's instructions. Fourth is proper grounding and bonding. Grounding and bonding are essential for electrical safety. Ensure that all electrical equipment and systems are properly grounded and bonded to provide a low impedance path for fault currents. This will help to protect against electric shock and minimize the risk of fire. Fifth is safe work practices. Always follow safe work practices when working with electricity. De-energize circuits before working on them, and use appropriate personal protective equipment such as gloves, safety glasses, and insulated tools. Be aware of the potential hazards associated with electrical work, and take steps to mitigate these risks. 6 is proper labeling and identification. Label all electrical panels, circuits, and equipment to clearly identify their purpose and function. This will help to prevent confusion and ensure that the electrical system can be easily maintained and serviced. 7th is regular inspection and maintenance. Conduct regular inspections of electrical systems to identify any potential problems or hazards. Perform routine maintenance such as tightening connections, cleaning equipment, and replacing worn or damaged components to ensure that the electrical system operates safely and reliably. 8th is documentation. Keep accurate records of all electrical work performed, including plans, specifications, and test results. This documentation will be valuable for future maintenance, repairs, and upgrades. 9th is professional consultation. When in doubt, consult with a qualified electrical engineer or contractor. These professionals have the knowledge and experience to provide guidance on complex electrical issues and ensure that electrical work is performed safely and in compliance with all applicable codes and standards. 10th is ongoing training. Stay up to date on the latest electrical codes, standards, and technologies by participating in ongoing training and education. This will help to ensure that you have the knowledge and skills necessary to perform electrical work safely and effectively. In addition to these general considerations, there are also some specific best practices that should be followed when working with RGS Conduit. First, proper cutting and threading. When cutting RGS conduit, use a pipe cutter to ensure a clean, square cut. Thread the conduit using a threading machine or a hand threader and ensure that the threads are clean and free of burrs. Second, reaming. After cutting and threading RGS conduit, ream the inside of the conduit to remove any sharp edges or burrs. This will help to prevent damage to conductors as they are being pulled through the conduit. Third, using proper fittings. Use only fittings that are listed for use with RGS conduit. Ensure that the fittings are properly tightened to provide a secure and watertight connection. Fourth, supporting the conduit. Support RGS conduit in accordance with the NEC requirements. Use conduit hangers or straps to support the conduit at intervals that do not exceed the maximum spacing specified in the code. Fifth, grounding and bonding. Ground and bond RGS conduit in accordance with the NEC requirements. Use grounding bushings or bonding jumpers to ensure that the conduit is properly grounded and bonded. 6th, protection from corrosion. RGS conduit is typically galvanized to protect it from corrosion. However, in some environments, additional protection may be required. Consider using a corrosion-resistant coating or wrapping to protect the conduit from corrosion. 7th, proper installation techniques. Follow proper installation techniques when installing RGS conduit. Ensure that the conduit is properly aligned and supported, and that all connections are tight and secure. 8th, inspection. Inspect RGS conduit installations to ensure that they are properly installed and comply with all applicable codes and standards. Look for any signs of damage or corrosion, and make any necessary repairs or replacements. Remember that local amendments to the NEC can exist. Always check with the local authority having jurisdiction to confirm any local electrical code requirements that might be different from the NEC. Always use appropriate personal protective equipment, or PPE, such as safety glasses, gloves, and appropriate work shoes for the task. Before working on electrical equipment, verify that it is energized using appropriate test equipment such as a properly rated voltmeter. Lock out and tag out the electrical disconnect to prevent accidental energization while working on the equipment. If unsure of the task, it is always best to consult a qualified electrician.